Hi grade 9s, here is the third and final example for the week 7 day 2 work. So again, we're going to go through the steps and find the rate of change, the initial value, and the equation based on this table. So this is very, very similar to all of the kinds of questions that you guys are going to be doing in the homework for today. So again, we're going to look at the table and it says, what does the rate of change and what does it represent? So I'm going to write rise on the right-hand side and run on the left-hand side. So I see here that I can see a pattern. What's happening to the numbers in the rise side of the table, in this dependent variable side? It goes 20, 18, 16, 14. So I do see a pattern, but it's a little bit different. It's going down by 2. So I'm going to put -2 there. It's going down. Okay. The run, again, I've got 10, 15, 20, 25. So the run, these numbers are increasing by 5. And we know from the previous examples, we've got our formula for ROC is rise over run. And here it's -2 over 5 because it's going down. And when we divide, we've got the number part the same. Once again, it's 0.4. Now we have to look at what that represents. Remember, our rate of change is our unit rate. So my units here, the rise is height and the run is seconds, the number of seconds. So this means it's a unit rate of meters per second. And if it's negative, it's going down. So this means the height is going down by 0.4 meters per second. And that down comes from the fact that we have a negative sign. We see that that's decreasing. So my next step is to look for the initial value. And just like in number 2, I don't have such an easy time here to find the initial value because I don't see a 0 in the left-hand column of my table. So just like in number 2, we have to do patterning back and follow the pattern to find where the 0 would be. So if I'm counting by 5s here, if I went back one step, 15, 10, one step less would be 5 over here. If I pattern this back, this is a little bit different. What would happen on that second column? Here, it's actually increasing as you go up. The numbers up here are going to be higher than the numbers down there. So it's 14, 16, 18, 20, 22. So if we pattern that back, it actually goes up because we've got that negative rise. It's decreasing all along. I'm going to do that again because I'm still not at 0. I draw an arrow up, pattern this back, 20, 15, 10, 5. Now I'm at my 0. And I'm going to pattern back this side as well. So I'm going by 2s and I would have a 24. So I'm going to circle that. That's my initial. So what's the initial value and what does it represent? The initial value is 24 and the 24 is in the height column. So the initial height is 24 meters because that's the units. So my initial height is 24 meters. The next step, I'm supposed to write a sentence describing what's happening in the table. So I know that I have an initial height of 24 meters and the height is going down by 0.4 meters per second. So maybe something's falling, you dropped a ball out of your window, something like that. Oh, I guess that's a very high window, 24 meters. But that's a sentence to describe it. So the initial height is 24 meters, decreasing or going down at 0.4 meters per second. So the height is going down. Maybe this is a hot air balloon and it's coming into land. Lots of different things that this could represent. But we don't have the situation. We have to think of something that could be the situation for this. So the last step is to find the equation. Now remember, finding the dependent and independent variables. My independent variable is always on the left, and my dependent variable is always on the right. And I know it gets a little bit crowded here, but my dependent variable is height. So I'm going to put h for height equals. Then I start with the initial. So wherever my initial is, I'm going to put 24. The next step is a little bit different than number 1 and 2. Remember that we had that plus and minus. You have to decide, is it going up or down? And if you look at these numbers for height over here, we see that they're going down. So that's one where we have to put a minus. And then the rate of change is 0.4. And that's kind of that negative in there, reminds us that we have to put that minus. 0.4, and then we put the independent variable. You could use n for number of seconds, but I might put s for seconds because that's a bit more descriptive. So h is the height and s is the seconds. You maybe could use t for the amount of time. That would work too. So that's the last example. I did just want to point out, and this is on your note as well, just a couple things that are important to remember. So when you're building your equation, the initial value is always the number by itself. So you can see, and we really color coded these, the initial value was the one that's off by itself. The rate of change is always multiplied by something because that's our unit rate, so you have to have a letter with it. When you're choosing your letters, you always want to use just one letter to represent something. So for instance, if you had kilometers, you would just write just the K, not K and M together. We're not going to put any units, so no dollar signs or kilometers or meters or anything. If you have a rate of change of 0.25, you just put 0.25 even if it means 25 cents. So I hope that that helps. You guys try the homework now, and that is it for this week.